Thank you for joining us today for our webinar on Stop Short-Circuiting Your Hard Work. Today we'll talk about what does short circuit mean and what are the proper perimeter and penetration treatments for acoustical applications. I'm Tonya Levine, Director of Sales for Building Acoustics, and joining me today is Chris Williams, our Territory Development Manager. Take it away, Chris.
All righty, thanks, Tonya. So, short-circuiting in this wonderful world of acoustics we find ourselves in can imply or be defined as a couple different things or acoustic phenomenon. I think a lot of times short-circuiting can imply or be referenced into the world of audio, sound systems, wave interference and waves canceling out other waves, etc. Today, for the purposes of this presentation, we're going to be focusing on short-circuiting as it relates to construction materials or systems within a building. So let's start with applications, acoustical applications. So we have our floated floor and suspended ceiling isolation systems or resiliently supported ceiling isolation systems that are, of course, designed to prevent the vertical, the up and down transmission of structure-borne sound energy. So from, and airborne for that matter, we're going to focus a little bit more on structure-borne energy, and we'll get into that. But the vertical transmission of structure-borne sound energy from one room, from source room, to the receiver room or the space above or below. So on that note, there's also a considerable amount of structure-borne energy traveling laterally, side to side, from the floor ceiling and into the walls, from the isolated floor ceiling for that matter, into the non-isolated walls. So if the flooring, if the floated floor or resiliently supported ceiling is in direct contact with the walls, the energy can easily be transmitted into the walls and anything for that matter that they're in direct contact with. So screws, studs, framing, all components to that wall. And to this extent, the energy can be heard or felt in adjacent rooms. So that structure-borne energy, that impact noise into the suspended ceiling or that floated floor transmits as structure-borne, is directly connected to that wall, which it of course should not be, and that's what we're talking about today. But if it is, you get that structure-borne energy into that wall, and that re-radiates out as airborne sound, so it becomes audible. And depending on, I suppose, the frequency spectrum of the source and really the guts of the building and what's connected to what, it can be audible in the rooms above and below. So our trusty acoustical consultants through the design phase, as we all know, will proceed to provide specific STC and IIC ratings for floor, ceiling, and wall assemblies. STC and IIC for floor ceiling, and STC for the wall. Our consultants also are aware that, fun fact, the speed of airborne sound, so sound traveling through air, is about 1,130 feet per second, and much harder to control is the structure-borne sound, which, depending on the construction, the materials in the building, whether we're talking about steel, whether we're talking about wood, etc., structure-borne sound travels at a rate of about 10 to 15 times faster. So you can imagine, upwards of around, once it gets into that guts of the building, once that impact noise, whatever the source, gets into the building, that sound is traveling upwards at a rate of about 15 or 16,000 feet per second. So we have our short circuiting of the floor ceiling systems to the wall assembly. compromising the STC rating of the wall and or the STC IIC rating of the floor or ceiling. Depending on the nature of the source, like I talked in the slide previous to this slide. So it's whether, we're talking about low frequency, high frequency, it depends a little bit on that. But certainly, if construction materials, if we're structurally connecting materials and systems that should not be connected, it will absolutely diminish the STC and IIC, just depending. So, and of course, as a result, we have our lawsuits. We will have time and energy and money, spent trying to remediate those issues. We'll have our vacancies as a result of all this. We'll have some problems. So, what is the definition of an acoustic short circuit as it relates to this particular presentation? An acoustic short circuit occurs when structural sound energy transmits between isolated structures and non-isolated structures. So we have our structural impact noise. Let's see here, we see some heavy weights and heavy weight drops. We have our structural impact noise transmitting throughout the isolated, whether it's floating floors or suspended, resiliently supported ceilings or both, into those non-isolated adjacent walls, as you kind of see there, or between acoustically coupled party walls in the building structure. So there's a lot of different sources of the structure-borne sound energy getting into the building. We have footfall noise, of course, which is typically mitigated by resilient underlayment. No need for jackups or anything of the like for that matter. So we have our resilient underlayment addressing the footfall noise. We have our weight drops, can become very problematic. And any sort of fitness related activities, repeated momentum of a treadmill or anything related to fitness. Of course, the children running and jumping in a multifamily, high-rise building. Mechanical equipment vibrations, absolutely. Yeah, so all of the above.
So what does a short circuit look like in section details? In this particular case, if you look at the image to the left, there is no perimeter treatment. What this is going to do is this is going to cause a hard connection with the structural slab, which will allow noise and vibration to travel from the structural slab into the isolated space, as what was mentioned by Chris earlier. Now on to what does it look like in the field? Well, in this particular case, there's been no perimeter treatment at the sliding door. And again, as Chris mentioned, this can have possible complaints and even lawsuits from the residents below and will need to be addressed. So what is proper perimeter isolation? And what does it do? It prevents that short circuit and prevents structural sound transmission into the isolated spaces, thus maintaining recommended STC IIC ratings for construction assemblies as designed by the Acoustical Consultants. And this can cause an upwards of plus or minus 6 to 10 STC points.
Yes, and I interject here very quickly, but that 6 to 10, I'm sure we'll get asked where we got that. That number comes from a variety of field tests I've reviewed in the past as a consultant, and a lot of internal theoretical assessments and calculations Kinetics has conducted with respect to a before and after wall mat, which we are working on a lab test here soon for that to show the the flanking noise transmission, insertion loss differences there. But it's pretty safe to say, and again, depending if we're talking about wood or steel and the guts of the building itself, and the impact, so there's a lot of variables there. But that's generally what we can expect with relatively severe short circuiting floors and ceilings directly connected to that wall, the STC rating of the wall.
So how do we address these short circuits? Well, in this, if you remember that earlier detail, by adding a perimeter treatment, such as perimeter penetration isolation, or PPI, an acoustical sealant will help prevent that noise and vibration from traveling from the structural slab into the isolated space. More examples of proper perimeter and penetration treatment. On the left, you have one of our rim isolation floors where it's using the resilient interface, or PPI. And then over on the right, there's two different types of sealing applications. One of it showing what needs to be done at the perimeter by using the resilient interface of CPT. And down below is what is happening with two hangers that are bumping into, or having an isolated ceiling bumping into a beam, a penetration treatment. And that's using, again, that resilient interface CPT by Kinetics and acoustic sealants. We wanted to thank you for joining us again today and see if there's any questions on things that we've covered.
Is flanking another term for short circuiting?
Yes, you can interchange the two. Yeah, you can. Flanking is maybe not in 100% of cases, but what we're trying to mitigate is the flanking noise transmission up and over the wall, diminishing the STC, so from source to receiver. So you can, for the most part, interchange the two terms, yes.
Okay. Another one, what is the density of the PPI material, and have you even done any STC tests with the PPI exposed in the test chamber?
We have all of that information, that the density of that is available online. I can actually send that information over, and then I'll leave the second part of the question over to Chris.
There are lots of field test reports out there showing the effects with and without perimeter isolation. We have not, to my knowledge, conducted a lab test, a STC test, for with and without use of the perimeter isolation, if that was the question.
Okay. Another one, do you provide solutions for reducing low frequency noise?
Yes, absolutely. Kinetics as a company certainly provides solutions. We have a lot of products that address that in conjunction with other materials and other construction materials. We can continue that conversation, but at this specific market group with our jack-up floors, our spring isolated systems, our rim system, ISOMAX in comparison to like a resilient channel and some of the other competitive clips out there, performs better in the low frequencies. So yeah, when using our systems and materials in conjunction with other materials, certainly addresses low frequency. We're talking STC and IIC with the PPI and the perimeter isolation material. That's not necessarily, though it has an effect on low frequency. STC and IIC, of course, don't reference specifically low frequency performance, but I'm happy to get into that a little bit more after this presentation for sure, as far as what we offer to address low frequency noise.
Do you get much resistance in the field from contractors implementing these details?
Yes. A lot of times it's just by, one of the reasons why we did this is because of what happens with the contractors is they don't see the need for it, and they don't realize, like why it's needed and the purpose of it. So this is, like by putting this together, we hope to show them that there is a purpose, because there's a reason why we have this done, is to prevent, as we said earlier, all of the issues that can arise by not using any type of a perimeter treatment or penetration treatment. All right, if there's any other additional questions, again, please feel free to reach out to us by either by phone, as what's available on the screen, or by our email, which is arcsales@kineticsnoise.com. Again, we thank you for joining us today.
Thank you.